Ladies and gentlemen, it's Phil Plait. Can you hear me, Phil?
Yes, I can. Hi, Matt.
Hey, welcome. I don't know if you were on when I said that we're in this not typical location. I'm at 9th Street Elementary School in downtown Los Angeles because we're part of a science fair or a science day event here. I was committed to this before we realized that this was going to be the best day to talk to you. And so here we are, and we're going to pick up a little bit of an audience here as well. You may be able to hear, I got a PA system running in the background. But Phil, thank you for joining us.
My pleasure. Thanks for having me on. I'm sorry I'm a little bit late. I'm having some technical difficulties, but everything seems to be good now. The only thing I'm missing is a power cord for my laptop, so hopefully it'll last long enough. We'll see.
Same for me. We didn't have an extension cord long enough, so maybe we'll both lose power at the same moment.
Oh my gosh. Okay. Yeah.
All right. Let me give you
problems.
As if you need it, let me give Phil the introduction that he deserves. Phil Plait, otherwise known as the Bad Astronomer, which he is not and never has been. Oh, good. They chose this moment to make an announcement.
I hope it's recess and then all the kids come screaming out.
They are just wrapping up. We've been making buttons at the Planetary Society table here. Actually, the project scientist for Juno was here, also handing out stuff about his mission, which is pretty exciting. I don't know if you can hear me. I'm going to assume that other people can too. I think that's the principal talking about how they're closing out the event today.
It's just in the background. It's not bad.
Good. Anyway, Phil has been writing about the cosmos full-time for almost 16 years now. I think I got that right. Under Alien Skies, A Sightseer's Guide to the Universe is his third book. It follows Bad Astronomy and Death from the Skies, which, by the way, is also great fun. Check out everything that he's up to at badastronomy.com. I am a paid subscriber to his newsletter/blog. I've been that way for quite a while, and it is also great fun. I've been happy to see your byline, Phil, appearing more often in my second most favorite magazine, Scientific American. It's way up there. Laura Helmuth, the editor-in-chief of Scientific American, says this about Under Alien Skies, that Phil Plait is a warm, funny, and welcoming guide to the most marvelous places in the universe. Our own Bill Nye says, Philip Plait takes us to nearby worlds and star systems far, far away, where we do plenty of exploration, a bit of astronomical science, and a lot of marveling. But it's the descriptions of your spaceship and suits that will keep you strapped in and reading on. His flights of science fiction fantasy are scientific and absolutely spectacular. Enjoy the rides. Not bad from the science guy. And Phil, he's right. I have absolutely enjoyed the rides. Really excellent book, which is also what we've been hearing from a lot of our members.
Thank you.
So first thing I want to do is forgive you for turning or for shrinking the Earth down to the size of a grape and turning it into a black hole.
That was fun. The book, the whole idea behind the book, right, is to discuss what it would be like if you were someplace else, on the moon, on Mars, on Saturn, or you're orbiting Saturn, and to talk about what it would actually be like, not just what you see, but what you experience, what you feel, sometimes what you hear, things like that, and to really immerse the reader in those environments. And the idea came out because I get asked this a lot. You take and Planetary Society, I've been to one of these, will have star parties or have people out in the public with telescopes and things. And whenever you show somebody something through the telescope, that's a question you get a lot, is what would this look like if I were there? And that's sort of the question I wanted to answer with the book. The thing is, with the book, I had to pick some interesting places, which is not hard because the universe is an interesting place. But also I had to do a lot of math. And what I found was writing about black holes. There's a lot of misunderstandings about black holes. And one of them is people think they have kind of like infinite gravity and they'll pull you in no matter how far away you are. And that's not really correct. And that black holes are huge, and that's not really correct. And one of the things I had to describe was tides. Was basically the idea that as you approach a black hole, the gravity is so strong that sort of the front side of an object might be pulled harder than the back side of an object. So as you're approaching a black hole, the part of you that's nearer to it is being pulled more strongly. And that is a difficult concept, it turns out, to describe. It takes 1,000 words, and in the end, you're like, well, you kind of forgot what you started out talking about. So when I talked about the Earth, I said, imagine the Earth is pulling on you, which is not hard because it is, and the near side of it is right underneath your feet, but the far side of it is 8,000 miles away. And so if there's a rock right next to you, it's pulling on you a lot harder than a rock on the other side of the Earth. But if you shrink that down to where the Earth is about this big, about the size of a grape or a golf ball, something like that, then the far side of the Earth is actually a lot closer to you. So all of that gravity, all of that mass is crushed into such a small volume that it's all pulling on you all at once, as opposed to it's sort of the same amount. I describe this better in the book. Off the top of my head, I could read from the book, but this idea was so complicated, and when I kind of stumbled on this idea of talking about where mass is and where it's pulling on you, when you shrink the Earth down, the concept becomes a lot more natural of how a black hole works, but why the gravity is so intense. And I was pretty pleased with that, actually. So crushing the Earth into a black hole actually turned out to be very advantageous for my narrative purposes.
And you did take us right there. Listen, you had me right from the start when you had your stand-ins for the rest of us go out there in their spacesuits on the lunar surface and, stretch out on like patio lounges and look up and watch a total solar eclipse happening as the shadow crawled across the surface of Earth. That was it. I have to tell you, though, that my favorite, the one that I would most like to experience, and I heard from several of our fellow readers who felt the same way, was that trip within the Orion Nebula. I would so like to be in the nose of that spaceship, that transparent nose, and just be surrounded by that colossal, stupendous beauty.
Well, thank you. The moon idea. So each chapter in the book is about a different object: Mars, an asteroid, a nebula, and they start with a short vignette. It's sort of a science fiction story of somebody, and it's told second person. So you are experiencing this phenomenon or this environment wherever you are. And in fact, when you write a book, you have to pitch a chapter. You have to pitch the idea to a publisher, but they want a sample chapter typically. And I wrote one about globular clusters, as it turns out, but that wasn't the first thing that I thought of. The first thing I thought of was the moon. I laid out sort of the chapter outline: the moon, Mars, what did I say, asteroids and comets, Saturn and Pluto in order. Moving outward in the solar system and then beyond. And as I was writing the chapter outline, before I wrote the sample chapter, my very first thought was, I want somebody to be standing on the moon and experiencing it, but what about the moon do I want to describe? And that's when I realized, the coolest thing would be a solar eclipse it's a lunar eclipse as seen from the Earth. It's a solar eclipse is seen from the Earth, but you're on the moon seeing the shadow of the moon crossing the planet. And so I wrote it as the point of view of somebody seeing that. And that was the first sort of thing I wrote for the book. And then for the sample chapter, I decided to go with a globular cluster for other reasons, but that was always on my mind the whole time before writing the book, because it seemed the most grounded, weirdly, because it's not the Earth's ground, it's the moon's ground. But it seemed like something that it was something we might experience because we've seen people on the moon. We've seen close-up pictures of the moon. We know what it's like to walk on the moon, maybe not first person, but seeing it with other people. And so that was always sort of thinking about doing something extraordinary, but grounded in things that we've already experienced, or at least have that hook. And it was a lot of fun to write that. I wrote and rewrote that opening vignette a lot, tweaking it here and there just to make it fun. Oh, and in the second half, because good heavens, there's nothing I can't talk about for 20 minutes in answering a short question. This idea of writing this book actually I wrote an article for Astronomy Magazine back in 2003, and it came about because I was talking with a friend of mine, another astronomer, about nebulae, about gas clouds and what they would look like if you were in them. And it's weird because you see the Orion Nebula through a telescope, and it's this magnificent object with all this structure and these colors. And it occurred to me that in a lot of these gas clouds, you could be in them and not even see them, not even be aware of it, because then that gas is spread out all around you, all over the sky. So instead of having this all that light concentrated in one small section, you're taking it, diffusing it everywhere, and it would be really faint. And in the Orion Nebula, there is some of that. Some of that gas is spread out around you, but there's also this backdrop of this dense molecular cloud, a very cold, dense cloud of gas and dust that is very, very thick, and it's sort of to one side and glowing because of the reflected light of all these stars, as well as the heat from all these stars. And it was a hodgepodge trying to write all this without making it super confusing, because there's a lot going on and a lot of it's complicated. And so describing that in a way that's understandable, so that without breaking sort of physical laws to do it, was an interesting experience. I'll phrase it like that.
I was somewhat in awe throughout the book of the work that you put in. You already talked about all the math you had to do, the enormous amount of work to figure out all the numbers and what things would look like, particularly as you changed your viewpoint. Really great work. I also told everybody, all of our members who were reading the book along with me, that they don't miss the footnotes, because they reminded me of, like, you know how an advent calendar works, and you open up the little door and there's a little treat inside? That was what the footnotes were. They were great fun. And really, you haven't gotten full value out of the book if you haven't done the footnotes. Go back and look at them again if you haven't done that already. It goes on. My pleasure. It goes on and on, but we really need to get to the questions that are coming in from the other folks who've read the book, and they're showing up over here on my second screen. I am going to take a look first at, well, here's one that's timely from Philip Shane. Did Phil watch the NASA conference on UAP today? There was we used to call them UFOs. I saw that there was going to be a NASA report from their commission, I think, that has been looking at what is it, unidentified aerial phenomena, something like that. I don't know, Phil. Were you in on that?
No, I'm actually on vacation right now, and in a massively different time zone. So I was not even aware of it, to be honest. I didn't get a press release or anything, and I wasn't even aware of it until my editor emailed me this morning and says, "Do you want to write about these?" And my first inclination is, no. It's like, hey, do you want to write about horoscopes? No.
But you've never been asked about UFOs or aliens ever, have you?
No, my God. I have a whole chapter in my first book, Bad Astronomy, debunking sort of UFOs. And I actually had a big UFO guy, oh my God, apoplectic at me for saying these clearly wrong things. Which, he was full of baloney. What he was saying, everything he was saying was wrong, which is not surprising. But yeah, it's there's nothing new under the sun. I don't know what the NASA conference is about, but I have seen a lot of these videos. There was the big Navy pilot videos that came out a few years ago, and those surface a lot, that show cameras mounted on jet planes, naval jets, showing weird things. And over and over and over again, what we see in these videos is that video cameras aren't the human eye. And when they show something weird, it's because it's a machine, and it sometimes reacts weirdly to things like a distant airplane's jet engine, which is hot. And if you have an infrared camera and you're looking at a hot thing, it's very bright, even though it might not be bright by eye. And sometimes it's so bright that the camera will bleed a little bit, and you get these bright sort of spikes that come out to the side, or there's a glow around them, or it has a hard time focusing. And so you get a lot of these weird video effects that people say, oh, it's a transdimensional hyperdrive. And it's like, no, it's not. It's it's an infrared camera. And so it can be, when you look at these videos, what you're seeing can be very tricky to understand. You don't know, the camera's moving, the object's moving. You don't know how far away this object is. And so there can be perspective effects. I know there's one video that shows what looks like this object screaming across the water. And it's not. You're in a jet plane moving at hundreds of miles an hour, and it just looks like this thing is moving rapidly. It's not. You're the one that's moving. And so it's things like that. It can be very difficult to ascertain exactly what's going on in these videos, which is why I don't like debunking them, because I don't know everything. And if I see a video and go, well, I don't really know what's going on here, then I get 1,000 UFO people saying, well, clearly it's an alien object from another dimension. And it's like, well, or it's a balloon and I don't really know exactly how this is working. So, the old idea, the skeptic's adage, is that when you hear hoofbeats, think horses, not zebras. Unless you're in Africa on the plains or something. But in general, you shouldn't jump to bizarre conclusions when there's probably something more simple, like, I just don't understand what I'm seeing here, not aliens.
Good advice. I remember I wrote to you once because I heard from somebody who wanted to get on planetary radio with his book of proof that UFOs exist. And he said, Phil Plait can't explain this. And I wrote to you, Phil, and you said, yeah, I can't explain it because it's too stupid to try to explain, or something like that. If you want more of this, folks, go to badastronomy.com, because that's where Phil really takes on all kinds of stuff. There are no UAPs that I remember anyway in Under Alien Skies. So let's get to a question that is actually pulled from the book. I told you that the situation you depicted, which I wish I could most be in, would be there in the Orion Nebula, looking at the trapezium. But I neglected to ask you what Greg Jansen asks: what fictional alien sky would you, Phil, most love to be a part of, to be stargazing at, or in the midst of?
Well, that's easy. It's Saturn. That is special to me because when I was very young, my parents bought a cheapo department store telescope and set it up in the driveway, and I looked at Saturn for the first time. It was probably the first thing I ever saw through a telescope, and I was hooked. I mean, it was spectacular. And if you ask a lot of astronomers and a lot of astronauts, when did you know, or why did you become interested in space? And they will answer, it's when I looked at the moon through a telescope for the first time, or when I looked at Saturn through a telescope for the first time. For me, it was Saturn. And with all of the Cassini images that came back over a dozen years from that space probe orbiting that planet, the rings, the moons, the planet itself, everything, I could never get enough of it. And even though I'm technically a deep space astronomer, I studied exploding stars, I studied nebulae near exploding stars. That's what I devoted my career to when I was doing research. And I'm not a planetary scientist per se, although, I know a little bit about the planets. Saturn has always been that destination for me. And in fact, writing about it, I kept putting more and more in. And I had all these notes, and it's like, okay, this chapter is now 10,000 words long, and it's already 30% too long. And I kept thinking of more stuff to add, and I had to keep yanking it out. It was simultaneously the most fun and the most painful thing I've had to write in a long time.
Well, you handled it well. I'd love to have that view just inside the rings. And I have to mention, because I still can't get over it, just how thin those rings are, as wide as they are. And you point out, what are they typically like? Is it 40 feet or 40 meters in thickness?
It depends on where you are, but in many places they're as little as 10 to 15 meters, so 40 feet.
Yeah, amazing. All right, here's another one from Dave Fairchild, who also happens to be the poet laureate of Planetary Radio. Which of the viewpoints you describe do you think you have you know what? I'm going to back up one to a different Dave. That's where I got confused. David Floyd, any material that wound up being left out of the book that you would have liked to include and maybe we can look for in the future? Painful
yes,
question.
There was so much. Besides Saturn, where I kept describing stuff in the rings and then realized I can't continue to do this. It was just too much. There was a ton of stuff. I mean, anytime you write a book, especially a nonfiction astronomy book, it's always, there's just too much. And where do you draw the line? And so there are like whole sections. I'd have to go and I go back to my desktop computer and look at each folder where I'll have, like, under the lunar sky, under the Martian sky, and I'll have a file there, a Word document that's basically, stuff I had to pull, which is killing me. That's kind of the title. I can't believe I couldn't write about this in the book. And there's just tons and tons and tons of stuff. One thing that I left out, for obvious reasons, but was all the math. There's just a lot of it is pretty straightforward, like calculating how big something looks like if you're standing on a planet in the TRAPPIST-1 red dwarf system. So the TRAPPIST-1 is a small, faint red dwarf, 40 light years from the sun, and it has 7 planets about the size of the Earth. It may even have more, but we've discovered 7. And they're all huddled really close into the star. And so if you're standing on a planet, unlike on Earth, where maybe Venus is resolvable by the human eye when it's a thin crescent between you and the sun, just barely. But on TRAPPIST-1, the planets are so close together that they will be obvious disks in the sky. And so the question is, well, how big? And it's really simple trig. It's the kind of thing, you could do it in high school trigonometry. But that changes because the planets sometimes are close together and sometimes they're orbiting on the other side of the star, so their size changes. I had to write all that down. I had to figure out how big the orbits were. I had to figure out how quickly they're all moving around the stars, what they would look like from all the different planets. So if you're standing on planet D, how big is planet B and E and F look? And if you're on F, how big does B, C, and D look? It was like that. So I had to have like charts and everything trying to figure all this out. And there was another one where if you're orbiting a binary star, as the two stars are moving around each other, you'll experience seasons. But I had to figure out, well, how hot does the planet get? If you're orbiting one star and there's another star in your sky, or if you're orbiting two stars that are orbiting each other, how does your temperature change? And that turned out to be math that I knew how to do from grad school. But when I started with the equation that I remembered, I got an answer that was clearly wrong. And I had to back out and derive all this from first principles, which is not something I've had to do for 30 years. So that was interesting to actually have to look up some equations and really think about what this all meant. And then get numbers that I was like, well, does that make sense? And it turns out, the temperatures of a planet can change a huge amount when the two stars pass in front of each other and one star blocks the other. You've lost half your light and you've lost half your heat and the temperature drops. And I really wanted to make sure I had all that right. And one of these days, maybe I've got pages of notes. If I could put it out as a sleep aid, perhaps. Here, look at these equations and see how this all works. And maybe, if you have insomnia, it'll help.
Thank you for doing the heavy lifting for us.
But that's all behind the scenes. None of that is in the book. I just talk about it.
I'm going to use the host prerogative here to bring up something else that actually was in my notes. Here at the science fair, there was a booth that was staffed by people who are part of the 30-meter telescope project, the TMT, which apparently is kind of back on track, thank goodness. And when I told them that I'd be talking to you about Under Alien Skies, they said, "Ooh, great book." He said, "I love the chapter about globular clusters and binary and beyond that star systems. Ask Phil if he's read Isaac Asimov's Nightfall." I said, "Hey, it's in my notes. I was going to ask him about that." You know the story I'm talking about?
Of course.
It's a classic story. I'll let you describe it.
Sure. It's generally considered to be the best science fiction story ever written, which I disagree with, in fact.
I do too, but it's up there.
I think The Last Question by Isaac Asimov is actually the best science fiction story ever written. It's perfectly constructed. But with Nightfall, it's about a planet where a historian discovers that there are layers of, as they're digging archaeological digs, they find that there were previous civilizations on the planet that rose to great heights but then were destroyed. And this happened over and over again. They couldn't figure out why. And basically, I mean, spoiler alert, I mean, the story's like 80 years old. So if you haven't read it by now, come on, really. What happens is the planet is orbiting a sextuplet star.
Something like that, yeah. At least 5.
It's I can't think of the actual word. It's octonary, septenary, sextile star, I think is what it is. So yeah, there's 6 stars that are orbiting each other, and the planet's orbiting one of them or all of them. And basically it's always daytime in this planet sky. There's always a star up in the sky, except for once every few thousand years. There's basically all the stars are down except for one, and then the planet's moon, I believe it was, eclipses that star, and so the sky becomes dark, and it's the first time in thousands of years. And not only is that such a tremendous psychological burden on the inhabitants, but this planet's also located like near the center of its galaxy, and so instead of just having a few thousand stars, there's like 100,000 stars in the sky, and
which they've never seen. Right?
Yeah, right, exactly. And they've never seen any of these stars. So it drives them all mad, and they basically burn down their civilization. It's a very clever story, and it kind of sort of works. I mean, we do know stars like that. I think Castor, one of the twin stars in Gemini, which is up now. If you go out at night after sunset and look at Venus, Mars is to its upper left. Castor and Pollux are next to it. And I think Castor is a sextuple system. So, that does happen. Whether you could have a planet orbiting it and you're the center of a galaxy with an eclipse, I don't know. It's a science fiction story. But it's a brilliant idea. And, Isaac Asimov had a lot of brilliant ideas, and it is a really good story.
Hey, let me go to another one of these that is coming in from our listeners, our readers. And by the way, folks, if you know people who are upset, like a lot of our members in Europe, who said, gosh, that's just going to be too late to watch, make sure that they know that we're recording this, and we'll have lots of opportunities once it's posted to planetary.org for people to watch after the fact. But for those of you who are here live, I started to mention Dave Fairchild's question. Which of the viewpoints you described do you think have an actual chance of happening? Well, actually, a lot of them are happening, right?
Yeah, I mean, the first half of the book is all solar system objects, so any of them could happen. I was pretty careful to keep the science as accurate as possible, and so traveling to Pluto, kind of a stretch. Traveling to Saturn, it took Cassini a decade to get to Saturn, so it's not like something we can do easily unless we develop maybe nuclear drive spacecraft, which are technically possible. But certainly going to the moon, going to Mars, going to a near-Earth asteroid, those are all technically possible. We've done it with the moon. The second half of the book, which is all interstellar objects, that involves faster-than-light travel. And I even say that, I think, in the first chapter, outside the solar system, FTL, faster-than-light drives are technically not possible as far as we know, but let's pretend, let's just talk about this because this is fun.
Sure.
But even, I mean, the idea of watching a solar eclipse on the moon, yeah, absolutely. Standing on Mars and seeing the Earth in your sky, yeah, I mean, we have images of Earth in the sky from Mars taken by the rovers and the landers. The chapter about asteroids, I wouldn't say I took a liberty. I don't want to spoil that vignette because I had so much fun writing it. It was probably the most fun one that I had.
But most of these people have read the book. I certainly hope so.
I hope so too.
So go ahead.
I don't want to spoil it for people who haven't. But the situation the astronaut finds themselves in, the space tourist, I'm going to say on this asteroid. I'll give that spoiler alert. That could happen. And I talk about it in the chapter of the book that these rubble pile asteroids, they're not monolithic. They're not solid rock. They're made up of billions or trillions of small rocks all held together by their gravity. And they're not held together very tightly. And the surface is more of a notion than a thing. The OSIRIS-REx space probe actually had a boom that was going to touch the surface of an asteroid and collect a sample of rocks, and that actually pushed through the surface. and it went in 40 centimeters. It went in a long way. And if the retro jets basically hadn't have fired, who knows how far in that thing would have gone. So even that situation, which I read about, which was, maybe seems unlikely, I don't think it is. So I really, really, really tried to keep it all science-based and talk about, even floating in a dirigible, a gondola hanging under a dirigible, a balloon floating through Saturn's atmosphere. Yeah, that's technically feasible. There's no problem with that, except, getting there. But assuming that we have rockets powerful enough to do that, you could get to Saturn in a few days if you have a really, really powerful rocket. So floating in Saturn's atmosphere and looking up and seeing the rings in the sky above you and the things I describe, it's all science-based. It's all as realistic as I could make it.
I'm thinking of that chapter about asteroids and comets, and what came to mind with that vignette that you don't want to give too much away was a story by Arthur C. Clarke called The Fall of Moon Dust, which was just brilliant. And I'll just say, it's sort of the ultimate claustrophobic nightmare is what you depict and what Clarke also depicted.
Oh, right. I remember that. It's somebody who's trapped in a pool of regolith, right?
Yeah, it's like a bus on the moon, and he got a whole novel out of it. It's brilliant.
That's right. I read that a long time ago. Before probes landed on the moon, and we knew the surface was dusty, at least somewhat. It wasn't clear if you could land on the surface of something like that and not fall in. That was a real concern before a lot of the lunar probes basically just soft landed on the moon. And you could have these pools of quicksand or something like that. And then it turns out it's probably not that big of a deal, especially with the lunar regolith, the powder. This powder comes about from thermal expansion and contraction. As day and night on the moon, you get a huge swing in temperature, and that stresses rocks. When you heat rocks up, they expand. When you cool them, they contract, and over time that breaks them apart. And there's also micrometeorite hits and radiation from the sun that breaks these things down, and so you get this dust all over the surface of the moon. But if it were like talcum powder or something like that, then maybe if you had a big deep pool of it, maybe it might act a little bit like a liquid. But in fact, when you look at regolith under a microscope, it looks like volcanic ash. It looks like shattered glass. It's a nightmare. Yeah, and so these things stick together. And in fact, it's crunchy. It's like walking on potato chips or something like that. So you sink in, as you can see in the Apollo images and the video, but especially in the images of their boot prints on the moon. Their boots sank in, a centimeter, maybe less. And that was it, because it compresses and holds its shape really well. So it turns out not to be as big a concern as maybe we thought before we landed there.
It's a good thing. Let's find another one here. From Craig Griffin. If you had to leave one message or piece of information on an alien planet for another species to find, what would be that statement or thing to sum up Earthlings? One Trekkie to another, I think of that classic Star Trek episode where they pulled Picard into an entire fantasy of the end of their civilization. And
right, the inner light.
With the flute. Yeah, the inner light. Yeah,
the inner light, yeah.
Excellent show. Anyway, also not exactly in the book, but I mean, interesting question.
I guess it depends on the situation, right? Is this, are we visiting this planet and maybe aliens are going to visit, or is it sometime way in the future and there's a problem? There is an episode of a TV show from the 1970s, Space 1999. And if you're of a certain age, so anybody with graying hair, they remember that show.
Or no hair.
There is an episode where they think they're all about to die and they have to evacuate this moon base. And the moon has been flung out into the galaxy. It's a long story, but the moon is wandering the galaxy by itself and visits all these bizarre alien worlds. And the chief scientist leaves behind this message, a recorded message. And he says, if you find us, seek us out. We came to explore. We're imperfect. We've done our best. Sometimes that's not enough, but we're curious and we want to explore, we want to understand things. So please come find us and talk to us and share your experiences with us. I'm paraphrasing. And in a show that was very strange and had a lot of not great moments, that was a superior moment in the show. It was really, really good, really well written. And I think about that, like, come find us, come talk to us, and let's share our experiences. Let's find common ground, and use that as a bridge to discuss how we're different. And I feel that that's just of such basic importance. If everybody thought the same, if everybody was the same, this would not be a very interesting planet. It's the fact that we have our differences, and that are surprising. Who wants to be told something you already know? That might be comforting. If you like have the same kind of ice cream every night, like I do, that's good. It's comforting. It's wonderful. But then something surprising comes along, and it's interesting and different, and you go, oh. Those are the moments that we live for. So I love having this diversity of thought. And heaven knows, if we meet an alien race, that's about as different as you can get. And I would love to know, what they think and how they think, why they think the way they do. And not only does that show us that there are these differences, but it puts the way we think in contrast and makes us think about it in a different way. And I think that's one of the most important things we can do, is sort of step outside ourselves and say, why do we think this? And why do we think of it this way? And I love that idea. I think that's of critical importance.
What a wonderful response to a question that isn't addressed in the book. But by the way, Martin Landau and Barbara Bain, hard to beat in Space 1999.
Yes,
otherwise,
and it was Barry Morse who gave that speech. And
I'd forgotten he was in it. Yeah, right.
And you know what? I'm gonna disagree with you a little bit.
Okay.
Part of the fabric that I wove together in the book is the idea of how we view the Earth when we're looking at an alien world. How, when you think about, like, Saturn is very different than the Earth. It's got these rings, it's a gas giant. But on the other hand, you can drop down into the atmosphere where there is sort of a different chemical composition than Earth's atmosphere, and it's much colder, but where the pressure is the same. So you don't need to pressurize your capsule. You just need to have it sealed so that you keep the gases out. But in that sense, it's kind of Earth-like. And Saturn has a moon, Titan, which has a thick atmosphere that's mostly nitrogen, like Earth. But it's very different. It's very cold there, and the gravity's a lot lower. So this whole compare and contrast thing, which are essays I hated when I was in middle school and high school. Compare and contrast this and that. I hated those. But it turns out they're important, and it's an important thing to think about. So the whole idea of this book, nothing specific, like what you were saying, is I don't have anything specific where I talk about it, but just overall, this idea of standing on Mars and experiencing it, I want you to keep in mind how that's different than Earth. And you take a deep breath here. Have a glass of water. Look at our blue sky. You don't get to do these things on other worlds. And so it's a way of going out and traveling and turning around and seeing your home again for the first time, which it's a T.S. Eliot. I can never remember who wrote that poem.
That was T.S. Eliot. That's right.
Basically, that travel changes you, and it makes you realize, makes you see your home in a different way. And that's kind of the point of the book. Wonderful.
And I do like, at least when you're examining areas within the solar system, Saturn, Pluto, how you look back at Earth, which sometimes is kind of hard to find, like from the distance of Pluto. Let me go on to another question here. Let's see. From Amber Trujillo, my colleague and partner who's working behind the scenes to pull all of this together. Out of all the books you could have written, why did this concept draw you in the most?
Oh, that's easy. It's because the publisher rejected my first pitch. That's actually
down
true.
To earth.
Yeah, that's a true story. I had a list of books I wanted to write, and there was one that I've been itching to write for a while. And it's got an overall theme, and each of the chapters would cover variations on this theme. And the publisher didn't want it, and I thought, all right, that's fine. And so I set that one aside, and I'm going to write that one eventually. but the other one was Under Alien Skies. And the reason I didn't pitch this one first is, as much as I wanted to write it, I mean, I wrote about this 20 years ago for Astronomy Magazine. It is that as much fun as I knew it was going to be to write, I also knew how much work it was going to be. And I'm a fundamentally lazy person. So, writing this book I knew was going to be a lot of work. And it turns out it did take me a lot longer to write than my other books. And my last book, Death from the Skies, I had to read so many journal papers to make sure I was getting stuff right. And it was very difficult. But in this one, I was reading journal papers about stuff I necessarily didn't know about that much. I'm not an expert in planetary atmospheres or things like that. And so reading about all this stuff was much more difficult. The math was a lot harder. And just sitting down and getting the flow of it was an interesting problem. It's not, because this is not like my previous books, which are just sort of narrative. You're just, or where I'm just saying, or descriptive. Here's this galaxy. Look at this star. Here's how this works. It wasn't like that. I really wanted to write the science fiction vignettes, put you in this experience, and then back out and say, well, here's the history of this, here's the science of this, and now let's go back and do the next thing and see what else, then see what's next. And getting that to work, if it, I assume it did. Getting that to work was different for me and very hard. So that's why I didn't pitch it first. But this was always something I really, really, really wanted to write about. And so when I sat down and started to do it, as difficult as it was on many levels, it was always a joy. It was always a lot of fun to sit down and go, okay, where next?
I think you did it extraordinarily well. And this leads directly into a question that came in from Susan Stalker. Do you have a resource for information that you used more than anything else, or has most of the knowledge been tidbits of intelligence that you've picked up along the way? Well, we've partially answered that, and you do have an extensive list of sources at the end of the book.
That's a good question, actually. Nobody's asked me that question. A lot of it was just stuff I knew from, a long time ago. I've been an amateur astronomer since apparently I was 6 years old, and a research astronomer as well. And so a lot of this was, I don't want to say I just knew it, but in general, if you're inside a globular cluster, how many stars do they have? How bright are the stars? What colors are they? That's the kind of stuff I knew. But then sitting down, hunkering down, and it's like, well, can you even have a planet in a globular cluster? And my first thought is, well, probably not, because first of all, they're very old, and these stars formed when there weren't a lot of heavy elements like iron, for example, which is a big constituent of our planet. So can you even have an Earth-like planet in a globular cluster if you don't have the building materials yet? There just weren't any in the universe. And then you've got a million other stars that are close by, and they're all whizzing around the center of the cluster. How many times do you have a close encounter with another star that might yank your planet away? And so I had to start digging into that and getting into the NASA journal archives, basically looking up Astrophysical Journal, monthly notices of the Royal Astronomical Society, all of these professional astronomical journals, and finding papers on them. And so it was, if I'd printed them out like I had my last book, because that's what you did. You didn't just like read stuff on the internet, you printed them out. And I had a stack of, papers like this. I think my stack would have been much, much higher this time, because I read a lot of papers. And sometimes it was just for an offhand comment, like, how close do you have to be to your star in a globular cluster, such that close encounters aren't that big of a deal? Stars don't get that close together that often. So if you're close enough to your star, you're probably safe. And then it's like, well, yeah, but if it's a hot luminous star, like say a B-type star, how close can you get before you're cooked? And then it's like, oh, well, wait a minute. All those stars in a globular cluster are dead because the globular is old and those stars don't live long. So it was thinking like that. And then it was, so I just an offhand comment, a one-line thing. And I had to read like 5 papers to figure it out. It's like, well, in for a penny, in for a pound. I can't stop now. I want to make sure this is right. And honestly, Wikipedia was hugely helpful. And you have to be super careful because it can be wrong, it can be out of date. And so in the bibliography, I say, look, your first stop can be Wikipedia. That's fine, but check the references. Everything in Wikipedia, or almost everything, is referenced, and you can click on it. You can find the paper it's in, and so from there it branches out, and that was sort of one of my most useful references, besides the Astrophysical Database System, ADS, the NASA ADS and the archive, which is where professional astronomers and scientists publish their papers so that you can read them. Those two were hugely helpful.
So yeah, if you haven't already, folks, take a look at that appendix that lists a lot of the sources, because it's a great guide for further reading as well. Let's see. Linda Tolberg says, first of all, it's lunchtime in Australia, so good on you down there, Linda. Does Phil have a plan for the next book?
Well, first of all, thank you, because that's a vote of confidence that I'll live long enough to write another book. I try to write one every 10 to 20 years. And also that you liked it enough that you're asking about another one. I do. I still have that first one that the publisher rejected. And I've thought about self-publishing. I dabbled. I thought about that for a long time, and then realized that I would have to outlay a lot of money out of pocket to do that. And it's like, well, I don't know if this flops, this is going to be bad. An obvious choice would be a sequel to this book, but honestly, I don't know if I have enough to add that would be different. You could say, well, think about what would it be like in the center of the galaxy? What would it be like? I do talk about that in this book when I talk about going to Sagittarius A star, the black hole in the center of the Milky Way. But there's a lot more going on there. That was something I left out, actually. Somebody asked about that. There are all of these luminous B-type stars, these massive hot stars orbiting the black hole in the galaxy, and we don't really know how they form. There are a couple of ideas. And there are dust clouds. There's weird structures in the center of the galaxy. Our black hole may have erupted, may have had a huge amount of material fall into it that got super hot, and got so hot it basically blew away from the black hole. This is a possible thing. We see this all the time. It doesn't get inside the black hole. It gets near it, but then gets so hot that it blows away. So there's a lot of stuff to talk about there, or intergalactic space, or the Big Bang. That's highly theoretical. How would you survive that? But I don't know if it would be different enough to warrant a new book. And so maybe I was thinking about writing short essays and putting them on my newsletter, something like that. I don't know. I might do that sometime. But I do have other ideas for books. And one of them I'm going to keep under my hat, because it's science. It's not necessarily astronomy. It's still science-based. And I don't want to talk about it, because when you talk about something you want to write, you never write it, and people will steal it.
Andy Weir said very much the same sort of thing, almost verbatim.
Yeah. This is too bad, I think, steal. I'm not sure it's that great of an idea. But I also, writing Death from the Skies, my last book, and this book, they all start with these science fiction vignettes. And I really liked writing it. And I've written some sort of really short fiction stories recently, and I've really had fun doing that. I don't know if I have enough ideas to write a science fiction book, but it's something I've been thinking about, and something I might still do.
I was going to compliment you on that, because they read as very good fiction, and I think that that might be worth giving a shot. You're welcome. We are almost out of time.
Oh my gosh, that's
probably almost out of battery too, and I do apologize to everybody for the flashing that my camera keeps doing. Doesn't do that on the desktop system, so I don't know what that's about, but thank you for bearing with us. Let's see. We have from Greg Jansen, what information that you researched for this book made an impact? I'll plagiarize that a little bit and say made the biggest impact on you. Well, I mean, what was new to you? There was a lot of stuff that was actually, I thought I knew the universe pretty well, but you surprised me with a few things.
There was a lot of stuff that surprised me when I did the math, for example, like on these TRAPPIST-1 planets, and you could see them as disks. And that's really interesting because they're big enough to see by eye, and certainly with binoculars, of course. But you could see them go through their phases. And if you're on a planet and you see another planet on the other side of the star, it looks full, but as it comes around, you see it go through phases like the moon. And it gets bigger, right? It's getting closer to you as it goes around. Where this is happening with Venus right now. Venus is at greatest eastern elongation in a couple of weeks, which means it's as far from the sun as it gets in the sky, about 45 degrees. And it's kind of swinging around from the far side to the near side of its orbit, catching up to Earth, and it's going to lap us. And as it does that, it gets closer and closer. Perspective, it gets bigger and bigger, but it's also getting to be a thinner and thinner crescent. And it was just interesting doing that math and figuring that out. But I think the biggest surprise, and I'll try to be brief like I can, is that the moon spins once for every time it goes around the Earth. It's an orbital spin resonance. It's a lock, so that we always see the same face. It's spinning as it's going around. And the idea is that if you're standing on the moon, that means that the Earth is always in one part of your sky. It never moves. And it turns out, well, that's not true, because the moon's orbit is elliptical. And so sometimes it's closer to us and sometimes it's farther away. And as it does that, our perspective on it changes. We can see a little bit around one side and a little bit around the other. And its orbit is also tilted. And so sometimes we can see a little bit beyond the North Pole and a little bit beyond the South Pole. This is called libration. And if you watch videos of the moon's apparent size in the sky, it kind of makes this mesmerizing rocking motion. It gets bigger and smaller. It's really cool. But that means that the Earth does move in the sky. And it moves a lot, like 13 degrees, I think is the number. I'd have to look it up because I don't remember off the top of my head. It's in the book. And so that means that actually if you were sitting on sort of the near side, far side boundary on the Earth, on the moon, you could see the Earth rise and set over the course of a month. It would go up and then set because it's moving several degrees in the sky. And that shocked me. I did not think it moved that far. But I used planetarium software and did a bunch of math and drawings and convinced myself, yeah, it's right. It does.
You got one illustration in the book that 2 shots of the moon that kind of show that, yep, you can actually get a slightly different view of what's up there on to be seen because of exactly what you're talking about. We are just about out of time. I think I've gotten through most of the questions that have come in from others. There are 2 other things that I want to bring up. One, your epilogue, which is quite beautifully written.
Oh, thank you.
You're very welcome. And I want you to say something about the transition you made from the time when you first started to get excited about the cosmos and then became very depressed. And how you recovered from that to get the sort of wide-eyed wonder that you still share with the rest of us today.
Right. I wrote about that in the epilogue. I forgot about that. I was wondering where you were going. And it's like, oh, right. What was I depressed about? Oh, yeah. When I was in, I guess, high school, and I bought a telescope with my newspaper delivery money and started looking at stuff. What I was doing, I was such an obsessive nerd. I would go through Burnham's Celestial Atlas, if you've ever read these, the 3-part huge books that just list huge amounts of things to see in the sky. And I would write down the ones I wanted to see or look for or just whatever. And I realized that, Orion comes back every year. You observe it and then I'm done. I've seen everything in it. And then it's like, oh, but it comes back. And it's like, well, I don't want to see that again. I want to see new stuff. And then year after year after year, it's like endless repeats, endless reruns. And I thought, this is awful. We're going to, it's like seeing the same TV show over and over again. I don't want to do that.
Cosmic Groundhog Day.
Yeah, exactly. It might drive one a little batty. And I realized that, no, you don't. Well, first of all, you never run out of stuff. And I think that's true. I mean, certainly when Hubble was launched and JWST and all these other wonderful telescopes, there are new ways of seeing old things and new things to see. But also, you might run out of things to see, like, the Orion Nebula. If you have a small telescope, there are only so many things you can see. But every time you look at the Orion Nebula, you see something different. The weather's different. You have a different eyepiece. You have somebody else there with you, and you might see it through their eyes for the first time. It never ends. Whether you're seeing something familiar and it's like an old pair of socks that are comfy, or you're seeing something new in it, or it's a completely new object. The universe, there's way more than you can see, and way more than you can appreciate, way more than you can understand in a single human lifetime. So you never run out of this stuff. It's a jigsaw puzzle with an infinite number of pieces, and every piece you connect, there are 3 more pieces to put together, and that's the greatest joy of science, I think, is that you can, even if you can't solve the problem completely, you can know it well enough to see where the next horizon lies. And I think that is just the best thing that the human mind can conceive of, is there's always more to know.
Makes for a great finish for the book. I got just one more for you. It's even beyond the epilogue. In your acknowledgments, one Trekkie to another, you acknowledge someone who's also one of my heroes, Gene Roddenberry.
Yeah, it was important to me. It's still very important to me, but it was very important to me as a kid to have these stories. Star Trek, Space 1999, Lost in Space, which was terrible. It's objectively a terrible show, right?
Dr. Smith.
Yeah, exactly. The pilot's actually really good if you watch it, the original pilot. But these shows stretch my imagination, and I could picture myself going to these places and see myself doing these things. Which again, to bring back diversity, which I think is an important thing, to show people who are different than me. I mean, look at me, right? I'm stereotypical scientist, and so to have different people in these shows, because you want to see yourself on the bridge of a starship. You want to visit these places and have these stories impact you, and the imagination of these people broadened my own. And to watch, I'm still watching Star Trek now, all these new shows, and they're so much fun. And to read the stories, all the science fiction stories, these are real places in many cases. It's not a dot in the sky. Saturn is not a picture in a book. It is a world, and it's orbited by dozens of worlds, and it exists, and it's real, and we can imagine what it's like to be there, and that imagination can be grounded in the science that we have determined. And for me, that these stories that tell us how to be human, or that show us a path that we can follow to be human, that path is in many ways laid down by science and laid down by the other aspects of our humanity. And science is a part of that. And so for me, these storytellers, especially the ones who tell stories about science, that really, really speaks to me. And for me, it's just super, super important. And that's why I wanted to give a shout out to those folks, especially because they had their hand on the wheel of those ships, and let me look through the view screen to experience them.
If I was a really good host, I'd just let it end there, Phil, because that was a perfect finish. But I have to say, once again, one Trekkie to another, doesn't it bother you a little bit over and over when an Enterprise or another ship on Star Trek has to hide out? So they go into a nebula and they can't be seen anymore.
Well, technically, but yeah, I mean, it's there. When you're telling
like a fog.
This is actually important. So for the next 2 hours, I'm going to talk about stories. This is something I did not understand as a kid, but I do now. Stories do not have to be literal. They can be metaphorical. They can be allegorical, and you can stretch every story stretches reality in some way. The very foundation of a fiction story is these characters don't exist, or something like that. So you're already in a place where maybe the rules are different. So to have them hide out in a nebula, I'm okay with that, because we already know Star Trek can't happen. We haven't had the eugenics wars. The stuff that happened in the past that was the future for the original series didn't happen. That's okay. This is a story. And if you make it as accurate as possible, and they do have a science advisor, Erin McDonald, she's great, and they use her a lot to talk about a lot of this stuff. But if you don't know that a brown dwarf exists, that there's an object like this in between the mass of a planet and a star, and you see them using one as a gravitational slingshot to escape a Gorn ship. I'm a nerd. That's from one of the Strange New World episodes.
I'm there with you.
That's okay. because then you go, what is that? And you look it up and you find out these are real and that people study them. I studied them for a while with Hubble. So that to me is what's important. A story is inspirational. And so if it goes too far and breaks its own rules, that's different because you don't want to be brought out of it. But if it's bending the rules and is internally consistent and brings in things that can inspire your imagination, I'm all for it. The story is what's important.
And you've made me very glad that I brought that up. Phil, it has been great fun, as I knew it would be. Thank you for joining us. Thank you for this excellent book, which I hope is doing very well. Folks, if you loved it, you might want to put a review up on Amazon and give it those 5 stars that I think it deserves. I look forward to talking again sometime, Phil. And again, thank you very much for joining us here in the book club on the Planetary Society member community.
It's my pleasure, Matt. Thank you. And thanks to everybody who participated. I really appreciate it.
All right, everybody. Once again, this has been recorded and will be available on demand fairly soon. Thank you especially to Amber Trujillo, who again has been behind the scenes feeding me these questions and helped us get ready for all of this. And you will be hearing from her, of course, in the member community many, many times. I will be back in this setting, as I said, with Andrewian, when we will talk about Contact in about 1 month from now. One of the finest science fiction books and movies, I think, of all time. Again, Phil, live long and prosper and take care.
Thanks, everybody.
Bye-bye, everyone.